Hey guys, how's it going? Today we're going to be learning about Lewis structures. So let's do a brief overview of it, and then we'll get into some example problems, and I'll even tell you some special rules that you need to know when doing these problems. So the first things first, Lewis structures are just a diagram that show the valence electrons of an atom and how they are shared or transferred in a molecule. Helps with visualizing bonding, lone pairs, and how atoms connect. I've got a couple of examples below, just showing like, okay, this is a double bond, we've got single bonds, we've got hydrogens all around, we've got oxygen. This just counts for 3 hydrogens bonded to the carbon, and then with NH3, we've got a lone pair right there, just things like that, right? So it just helps us see how the molecules are oriented in space. And then there's a couple of steps we need to know before drawing Lewis structures. So the first step is to just make sure you know all the valence electrons. So it's helpful to have a periodic table pulled up when you're doing these problems. And then you need to just add up the valence electrons for each atom. For ions, add electrons for negative charges and subtract for positive. Step 2 is to choose the central atom. This is usually the atom that makes most of the bonds, often the least electronegative, except hydrogen is never the center. Hydrogen can only bond to one thing, so it can't have multiple bonds. Step 3 is to draw the single bonds. So that's just going to be connecting the atoms using single lines. Each bond represents 2 electrons. So the same thing here. So if you have CH, that's the same thing as this. Step 4 is to complete the octet of outer atoms. So you need to be adding lone pairs to outer atoms until they have 8 electrons. So for example, if you have H2O, you're going to have O. It's going to bond to H just like this, and then you'll have lone pairs completing that octet of oxygen, because there's 2 lone pairs right here, 2 lone pairs here, or not lone pairs, sorry, 2 electrons here, 2 electrons here, and then 2 electrons here, 2 electrons here, adding up to 8. And then step 5 is place the remaining electrons on the central atom. And finally, we're going to do step 6, which is make double or triple bonds if needed. If the central atom doesn't have an octet, move lone pairs into bonding positions to make double or triple bonds. All right, let's start by doing example 1. This one says, draw the Lewis structure for CO2. So to start, we need to count our valence electrons. Carbon is going to have 4 valence electrons because it is in group 14 or 4A. Oxygen is going to have 6 valence electrons since it's in group 16 or 6A. And then there's 2 of them, so we need to multiply that by 2. And that'll give us 16 valence electrons. From here, we need to start by identifying our central atom, which is going to be carbon in this scenario. Carbon is usually a central atom in most scenarios. And then from here, we need to use our oxygens and connect them to the carbon using electrons. So we'll do this and this. And then our next step is going to be to fulfill the octet on the outer atoms. So we'll fulfill the octet on oxygen by just adding electrons. And just like that, we have 16 valence electrons. But there's a problem. Carbon doesn't have a full octet. So in order to fix this, we need to bring electrons from oxygen and make a double bond with both of the oxygen atoms onto the carbon, which will look something like this. And that will give us a complete octet. One way I like to draw Lewis structures is just use lines to signify, okay, those are electrons, and we know that there's 4 electrons here and 4 electrons here. And then that would give us a complete Lewis structure of CO2. And from here on out, I'll just use lines and just imagine them as electrons. So one line will just be equal to 2 electrons. 2 lines will be 4 electrons. And then 3 lines, which is just a triple bond, will be 6 electrons. All right, from here, we can move on to our second example, which says, draw the Lewis structure of NH3. So this one's pretty simple. Let's start by counting the valence electrons. So you know N is in group 15 or 5A, so it's going to have 5 valence electrons. And then hydrogen is in group 1, so it'll have 1 valence electron, and there's 3 of them, so that'll give us a grand total of 3 valence electrons. In total, there's 8. So we'll start with nitrogen as our central atom, because hydrogen can never be a central atom because it can only bond to one thing. So nitrogen being our central atom, we'll start by connecting hydrogens to it. That's going to give us 6 total electrons that we used. So we still have 2 remaining, because if we subtract that, then it's just going to be 2 electrons left. So in order to complete this, we're going to actually put the lone pair on nitrogen So that's not going to be connected to anything. It's just going to be a lone pair of nitrogen, because remember, hydrogen can only have one bond. So where can those electrons go? On the lone pair of nitrogen. And that's going to be a stable compound for nitrogen. All right, let's draw the Lewis structure of SO4 2 negative for example 3. So for this one, sulfur will have 6 valence electrons because it's in group 16 or 6A. Oxygen's in the same group, so it'll also have 6 valence electrons. And there's 4 of them, so it'll give 24. Then we have 2 extra electrons, which will give us a grand total of 32 valence electrons. From here, we'll start with sulfur as our central atom, bonding to 4 oxygens. And then we can just complete the octet, all the oxygens, giving them each 3 lone pairs technically, or 6 valence electrons on the outside. And then it has 2 bonding electrons to the sulfur. That'll complete an octet, creating 32 total electrons, so that's satisfied. But the only problem is, there's another problem where they have formal charges. And the formal charges on each of these oxygen and sulfur atoms is not 0. And the most stable compounds have a formal charge of 0. So for this scenario, we would actually have to bring 2 electrons from 2 of the oxygens, making sulfur 0 and creating the 2 oxygen atoms to have a 0 formal charge. And then 2 of the other oxygen atoms will also have a -1 charge. But something that looks like this will be more stable. And then you'd have just the extra valence or lone pairs. And that's how you do the Lewis structure for SO4 2 negative. And then moving on to example 3, it says draw the Lewis structure for O3. So for this one, pretty simple. We just did it. There's 6 valence electrons for each oxygen atom. There's 3 of them, so there's 8. And then from here, we just make, obviously, oxygen our central atom, and we just bond it to 2 other oxygens. And then from here, we'd have 8 here, we'd have 8 here, and then we'd have another 2 here, which gives us 18. The only problem is, once again, with formal charges, this middle oxygen isn't satisfied, and neither are these 2 other oxygens. So what's going to happen is resonance. And basically what will happen is this will create a double bond, and sometimes that'll go back to a single bond, and this one will create a double bond. So it will really look like this, in which this double bond kind of flips between these 2 oxygens, if that makes sense. Except it's just electrons going back to lone pairs, and then therefore these electrons can then bond to that oxygen, which will give it a better formal charge. And then that's going to be it for the Lewis structures, besides a few special rules that I have to mention. So there's 3 special rules that kind of go along with this. Some atoms won't have a complete octet. There's atoms like hydrogen, beryllium, and boron that are stable with fewer than 8 electrons. Helium's also an exception, because boron would rather give up its electrons, so then it would only bond, for example, to 3 fluorines, kind of making it like that, and then that would be stable for boron. And then another rule is the expanded octet rule, which says atoms in period 3 or beyond, like phosphorus and sulfur, can have more than 8 electrons, like in the example we just saw with SO4 2 negative, kind of showed you. And then you also have SF6. And then one more rule is the odd number of electrons rule. It says some molecules have an unpaired electron, making them radicals. Example of this would be nitric oxide, which has 11 total valence electrons. So that's just going to be it for today's video. Pretty simple. I'll go more in depth and kind of do each specific Lewis structure as we go in other videos. If you have any questions, feel free to comment down below. And then, just leave a like and subscribe if you enjoyed it. Have a great rest of your day, guys. Bye.